Hi everybody, this is a video on significant figures, and by the end of this video you should be able to determine the number of significant figures in a value or the number needed to calculate in an answer. So first let's make sure we understand what significant figures are. So these are the numbers in a value that determine the accuracy or precision of a measurement. So we have all known values plus then like one uncertain value at the end, which is where we get our significant numbers. We have some rules to follow to determine if a value is significant or not. If your number is not 0, it's always significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, all of those are significant. Any zeros between non-zeros are considered significant. These are known as captive zeros or sandwich zeros. So 101, 101. That 0 in the middle is significant because it's between two non-zeros. Zeros to the right of a decimal and a whole number are significant all the time. So 1.10, okay, that would be a 0 to the right of a decimal and the right of a whole number. It is significant, so that number has 3 significant figures. Leading zeros, which are zeros before your first whole number in a decimal, so like 0.00002, all those zeros in the front are never significant because they are not after a whole number. And then zeros in a coefficient of scientific notation are significant because we did not drop them for a reason. So if you look here, this number, 0.0017, all these zeros up front are leading zeros, which means they are not significant. But this 1 and this 7 are non-zeros. They are significant. So in this number, there are only 2 significant figures. So we use the US of the SFs, which I call it the United States of Significant Figures, to help us see when zeros are or are not significant. Because if they're at the end of a number, like a trailing 0, sometimes they are significant. If there's a decimal, if there is no decimal, they're not significant. They're like leading zeros. So you will fly from coast to coast with a layover at your first non-zero. So we know that on this side of your United States is the Pacific Ocean. We're going to call this the present decimal ocean. And on our side of the United States, that's the Atlantic Ocean. So we have an absent decimal. So here are all our values. So you can write those down. I can't remember if I put them actually in your notes or if you need to write those down. And we're going to fly from coast to coast, Atlantic to Pacific, or Pacific to Atlantic, depending on if a decimal is in your number or not. So on this first number, as you see there, there is no decimal. So that means we're absent. So we're going to fly from Atlantic to Pacific with a layover at my first non-zero. Okay. Well, we have a 1 here, which means I stop there. And since I didn't mark anything out, that means all of these values, all of these places are significant. So we've got 1, 2, 3, 4. We have 4 sig figs here. Okay. So for the next one, again, absent decimal, we fly in. We can't move past that first 2 because that's a non-zero. So we've got 1, 2, 3, 4, 5. We have 5 significant figures there. Another absent decimal. This one should be easy though because there's no zeros, so it shouldn't throw anything off. We have 3 significant figures there. Here, we've got a present decimal, so you see that decimal in the front, but we don't stop till our first non-zero. So as you can tell, my line went through these first 2, which means they are not significant. So we've got 1, 2, 3, 4, 5. These 2 at the end, though, did not get marked out, which means they are significant. So we have 5 sig figs there. And this last 2 I put on here on purpose because they are a little tricky. One has a decimal and one doesn't. So you fly from different directions, okay? This first one does not have a decimal, so we're going to start on the right side. And since it doesn't have a decimal, we stop at my first whole number, or non-zero, which would be the 5. This number has one significant figure. Those zeros at the end do not count. However, the exact same number with a decimal has 3 significant figures, because I couldn't mark any of them out because that's where that decimal is located. So this is just a quick way to show you. You don't have to draw the United States, but you can fly from side to side to tell you kind of what does and does not count as significant. So now let's look at this example. Sorry for my typo here. How many sig figs are in this value? So first, we see that there is a decimal present. So we would start from the left and stop at my first non-zero. Okay. So when we do that, I'm just going to write on my problem. So we're going to start from the left. First non-zero. As you can tell, nothing gets marked out, which means we count all of these values as significant. So when you do that, you've got 1, 2, 3, 4, 5, 6, 7, 8. 8 sig figs in this number. So rule 3 from your previous list, zeros to the right of a decimal in a whole number are significant. So now you go ahead and you try this example here. Pause your video. So now let's talk a little bit about math with significant figures. So addition and subtraction, you actually don't care anything about significant figures here. We look at decimal places. So your answer that you calculate can have as many decimal places as the least number of decimal places within your problem. So what this basically says is, like, you cannot be more accurate than your least accurate measurement. Okay. And then for multiplication and division, we are looking at sig figs here. So it's the same rule, but instead of decimal places, it's sig figs. Your answer can have as many sig figs as the least number of sig figs within your problem. Once you've calculated that answer, so you will get your raw value and then you'll round, just like we normally do. So once you know the number of sig figs or the number of decimal places that you need, you will round using your greater than 5 up rule. So like if your rounder is 5 or greater, you're going to round up. If it's not, then you stay the same. So let's look at this example here. We're doing addition and subtraction, so that means we care about decimal places. So we get our raw answer first. And when you add all these up, you get 18.8184. Okay. So then we look at decimal places of each value in the calculation to know the amount that you can have in the answer. So let's see. This one has 2 decimal places. This one has 1, and this one has 3. So this one is the one that wins out here. It's the least number of decimal places, which means my answer can only have 1 decimal place. So it gets that 1 spot. But this 8 here is my rounder. This is the one that we look at to see if it's above or below 5. Okay. So when you look at that 8 is above 5. It's going to cause my 1 to round up. So my answer would be 18.2 here. So now it's your turn. You try this one. This is a division problem. So you're using your rules for division. So now you can determine the number of sig figs in a value and round your answers correctly.